Hello everyone, in this video I'm going to go over the ATC workshop 15 for Chem 1 TC. So this worksheet is going to go over the dicarbonyl compounds. We're going to go over the beta-carbonyl reactions and alpha-carbonyl synthesis, malonic acid synthesis, microaddition, Robinson annihilation, and alpha-hydroxycarbonyl synthesis and oxidation. So let's go over the first part here, where we have this starting reagent here reacting with the first reagent NaOH3, which is a strong base. So since we have a strong base, we're going to look for our most acidic hydrogen, which is going to be this alpha hydrogen between these two dicarbonyls here. We deprotonate that, and then we have this nucleophilic enolate ion here, where we reform the carbonyl and then attack our enone or beta unsaturated ketone here. Since this is a weak nucleophile, not a hard nucleophile like RMGBr, RLI, or NaH. So we would attack the fourth position doing the micro addition, and then I start the attacking carbon, dot the carbon being attacked. I make new bond between them, and then I reform this. I kick up the double bond here, kick up the carbonyl bond onto the oxygen, giving that negative charge there. I connect whatever is attached to the pink dotted carbon over here, and then I reform the carbonyl and protonate the enolate ion here, tautomerizing it into this ketone over here. And then we are going to use another strong base NaOH3 to deprotonate this alpha hydrogen here, which will then attack this electrophilic carbonyl carbon here, forming a 6-membered ring. And then after that, we are going to do the aldol dehydration to get rid of the alcohol. So here's the mechanism of it. The alpha hydrogen here gets deprotonated, forming the enolate ion here. This first carbon here will attack the 6th carbon, forming a 6-membered ring, attached to all the groups attached to the carbons. This O- here will get protonated by the HOCH3. And then after that, we're going to form the enolate ion over here. We reform the carbonyl. We grab the hydrogen that's alpha to the carbonyl and between the alcohol as well. We reform the carbonyl, move the double bond on the other side, pick out the bad living group alcohol. And then this bad living group alcohol is able to leave because we have enough energy for it to leave. And we're in basic conditions as well, which supports that living group to leave. And then giving us our final products here. So let's move on to the next one over here. We are going to use a strong base NaOH3 to deprotonate the alpha hydrogen between these two dicarbonyls, form our enolate ion over here. And then this is our nucleophilic enolate carbon over here. We reform the carbonyl, attack the electrophilic carbon over here, kick up the double bond to that carbon, giving that negative charge. And then that negative charge will get protonated, giving us our final product over here. Now let's go over this multi-step synthesis over here. The first step is a protecting group where we convert this carbonyl into the thioacetal. The second step is to make this alpha carbon here nucleophilic, which I start and then attack this dotted electrophilic carbonyl carbon over here, make the new bond between the starred and dotted carbon, attach what's attached to the dotted carbon, which is this O-, and then we do acid workup to protonate that OH, and then we do the deprotection step of the thioacetal to receive our carbonyl back, and then we use KMnO4 hydroxide, H2O, and heat to oxidize this alcohol into the ketone and oxidize this aldehyde into the carboxylic acid. And then for the next one over here, we have a strong base, and this structure here, the strong base is going to deprotonate this hydrogen, give that carbon a negative charge. This negative charge is going to attack the carbonyl electrophilic carbon over here, kick up the carbonyl bond to the oxygen, and then we make the new bond over there. This is the oxygen that got kicked up, which is going to get protonated. And then we do this same step again, where we use a strong base to deprotonate this hydrogen right next to the alcohol, give that a negative charge. The negative charge will then attack the carbonyl compound again, and that would give us this O- group here, which will get protonated again. And then we use a strong base to deprotonate the alcohol hydrogen, reform the carbonyl, and kick out this good living group over there, giving us our reaction over here. And then for this one over here, we have a strong base. We're going to deprotonate the alpha hydrogen between these two dicarbonyls, giving us our nucleophilic carbon over here, which attacks this in the SN2 fashion. This is our electrophile here. And then we add the new R group. We do the same thing again. We deprotonate the alpha hydrogen between these two dicarbonyls. We have a beta unsaturated ketone now, which we attack in the 4th position, or this is the micro addition. Move the double bond up here, kick up the carbonyl bond onto the oxygen, giving us this enolate ion here, which we reform the carbonyl and protonate this enolate carbon over there, giving us our final product over here. So thank you for watching. Please subscribe, like, and share this video.